Okay, we're going to pick up with video 2 of the ABS diagnostics on the red 2000 Freightliner FLD 120. We had 2 trouble codes, the first being that the bulb was burnt out in the dash and never turned on. The second code we had was for a front right steer axle ABS sensor. So it was actually listed axle 1, which is the very front axle of the truck, on this one, which is the steering axle, telling us that the right side, which remember that's always as if you're in the driver's seat, so that is the passenger side front ABS sensor, was either open or below voltage specifications. So that was our code. Now we're going to get into how to diagnose that. So the first step would be to check and see what the resistance and continuity through that speed sensor would be. So I know we haven't gone through electrical yet. That's later this semester and almost all of the second semester. So let's talk a little bit about dvoms here really quick. We have AC voltage, which this type sensor actually produces an AC voltage. It's a variable reluctance type sensor. So it's a permanent magnet with a bunch of, or one copper wire wrapped numerous times around that magnet. There's a video in the chapter that will show you kind of how that works and how the tone wheel cancels that out to generate an AC voltage. There is DC voltage, which is what we use on most all vehicles. Most of the time it's DC voltage, which is a straight line with the dots under it. AC voltage is alternating current, meaning positive, negative, back and forth. That would be more like what comes out of the electrical sockets in your house. We use it a little bit, and this is one of the examples we would use it on, is for an ABS sensor. So what it's going to ask us to do first is check that sensor for continuity and how much resistance it has. So to do that, we use ohms, which is our upside down omega symbol here. So for this first test, we're going to set it to ohms. Now OL means out of limits. That means that there is no continuity. It's unmeasurable. It's infinity. So no pathway. That's an open circuit. It's reading OL right now because both of my leads are not connected to anything. Speaking of the leads, remember that common is for the black lead. The black lead always goes in the common port on the DVOM. We're checking ohms, so we're going to put the red lead in this volt ohms diode socket here. It's a little bit hard to video all this one-handed, but here's our black lead. I'm going to plug it into the common, red lead into the ohms. We're set on ohms, so whatever you're measuring on this scale, whether it be the diode, the ohms, volts, 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 that all goes in this red port for the red lead here. We'll get into the amps part later. Don't do that until you've been through the electrical training, because you could damage the meter and mess something up. So if we take these 2 leads now that it's set on ohms, and a little bit hard to do one-handed, connect those together. Now instead of OL, we're down to 0, so that means we have no resistance. We have continuity through the circuit because these 2 leads are touched together. I went ahead and pulled up the procedures on Truck Pro Demand. So we've got our Mitchell here. Speed sensor troubleshooting gives us kind of an overview here on the front. Tells us kind of how the circuit works. We flip over to the other side. It gives us the harness connectors at the ECM. We're not really worried about that. What we're worried about is speed sensor resistance test, the correct resistance for the speed sensor circuit is between 950 and 1900 ohms. Okay. So I know the lighting is horrible, but inside the wheel here, if you remember when you took those apart, we talked about the tone wheel and the sensor that's on the inside of the hub. If we follow the electrical wire here, kind of follows the air brake hose to the modulator valve. It goes through the frame here. So on the inside is where the connector is at. I've got it disconnected. It was actually disconnected, which is what our problem was. But if we pull that out, you can see there's two wires inside here. Okay. Doesn't really matter which one for this particular test. That's what our service material says. So if we put our black lead in one of those connectors, the red lead in the other, if that sensor was open, we would get OL like we talked about before. So it's going to read OL. I can't measure this and video it at the same time. I did measure it, and the measurement on the sensor itself, ohming it out, was 1,124 ohms. If you remember our chart, that was within our range, so the sensor itself is good. The problem was that the sensor was unhooked, and I don't know if I can pull this other side of the connector up here, but it's actually quite dirty. It's got a lot of corrosion on it, so that could be a problem as well. The sensor itself would be corroded. I know it's trying to adjust, and this video was horrible, but the two pins that connect into the sensor have corrosion on the side of them. So that and the fact that it was unhooked would be why we had that particular trouble code and why it said that this sensor was not working on our self-test.